Welcome back to Lesson 5, Part 2. Our focus will be on instantaneous rate of change. Now, in Part 1, we took a look at the average rate of change and we said that it helped us determine how fast the y values were changing over a specific interval within the domain of a function. And we also emphasized the fact that the rate of change of the function at any point will be different, or at every point will be different. And then we posed the question, how can we determine the rate of change at a point? So at a specific point on this very instant, or in other words, the instantaneous rate of change. So we base the process, or we build the process of determining the instantaneous rate of change on the average rate of change. Knowing that the average rate of change is measured by the slope of the secant line from 2 points, 2 distinct points. Now we're thinking that to determine the rate of change at a specific point, say for example at the point A on the graph of this function, then we just need to bring the point B a little bit closer to point A. So if the point A had the coordinates A, f of A, we are assuming that we're bringing the point B very, very, very close to point A, such that the horizontal distance in the x-coordinate will be h, or a very small number, which we indicate by letter h. So we're going to say that the point B will have the coordinates A plus h, and as a result, the y-coordinate of B would be f of A plus h. So then the rate of change between the 2 points A and B, 2 nearby points A and B, will be determined by the slope of AB, which is the change on the y over the change in the x values. So it will be f of A plus h minus f of A over A plus h minus A. In a more simplified form, this would equal f of A plus h minus f of A divided by A plus h minus A, which is h. So if h becomes almost 0, then we are going to say that the secant AB will turn into a straight line that touches the graph only at one point. So B will be onto A, and the graph is touched, or the secant will touch the graph at one point. Now when a line touches the graph at a single point, we say that we have drawn the tangent line. And the slope of the tangent will measure the rate of change of the y values on the tangent line. Now it will help us determine the instantaneous rate of change. Of the y values. Now remember that to find the value of such function, f of a plus h minus f of a over h. If h becomes 0, it's impossible because division by 0 makes no sense. So instead of finding the value of the function, we say that we're finding the limit of the function as h approaches 0. So we're going to say that the instantaneous rate of change equals the slope of the tangent or the limit as h approaches 0 of f of a plus h minus f of a over h. So this is what we call the formula for finding the instantaneous rate of change using limits. And we are going to practice this formula in a few functions. So as a first example, here I chose a quadratic function, f of x equals x squared plus 3x plus 4, and we're trying to find the value of the slope of the tangent at x equals negative 2. Now, step number 1, we have to determine f at negative 2. So in our case, we have negative 2 squared plus 3 times negative 2 plus 4. That's 4 plus 4, 8 minus 6, that's 2. So we're going to say that f of negative 2 equals 2. And then we sub everything into the formula. Or I should say IRC formula, instantaneous rate of change formula. So what we have now is the limit as h approaches 0 of f of negative 2 plus h minus f at negative 2 over h. So that would be the limit as h approaches 0, negative 2 plus h squared plus 3 negative 2 plus h plus 4 minus 2 over h. That's the limit as h approaches 0. 4 minus 4h plus h squared minus 6 plus 3h plus 2 over h. Or the limit as h approaches 0 of 4, negative 6, and 2 will add to 0. We have the term h squared, negative 4h plus 3h is minus h divided by h. We factor out h. And that will allow us to simplify the h from the denominator. So that would turn into a determinate form limit. So now we can substitute h by 0, and we'll say that the rate of change of the function at negative 2 would be negative 1. So two things, the slope of the tangent equals negative 1, and instantaneous rate of change will be negative 1. So step 3, simplify, right? Now, I've brought in another example for you to try, 2x cubed minus 5, which means that I suggest that you try this on your own. I will continue simplifying this in here. So I'm going to find g of 3 first. So that would equal 27 times 2, 54, minus 9, 49. And then I'm also going to find g at 3 plus h because we have a cubic function. So we want to write things in simplified form when we substitute them into the formula. So that would be 2 times 3 plus h to the power of 3 minus 5, which would equal 2 times 3 to the power 3 plus 3 times 3 squared h plus 3 times 3 to the power 1h squared plus 1 times h to the power of 3, and then minus 5. So that would be 27 plus 27h plus 9h squared plus h cubed minus 5. So that would be 54 plus 54h plus 18h squared plus 2h cubed minus 5. So 2h cubed plus 18h squared plus 54h plus 49. So this would be g of 3 plus h. So now we have to substitute into the formula and evaluate. So this would be our steps 1 here and step 2 here. So in step 3, we'll substitute everything in. So we have the limit, the slope would equal the limit as h approaches 0 of g at 3 plus h minus g at 3 divided by h, or the limit as h approaches 0, we have 2h cubed plus 18h squared plus 54h plus 49 minus g of 3, which is 49, divided by h. Okay, just remember that would be our g of 3. And this one here is g of 3 plus h. So here is g of 3 plus h, and here is the g of 3. So the limit as h approaches 0, these two will always simplify to leave us only with terms that contain h, which will enable us to simplify the h from the denominator. So h, 2h squared plus 18h plus 54 over h. So, oopsie. Simplifies. And that will give us 2 times 0 squared plus 18 times 0 plus 54. The answer is 54. So the slope of the tangent drawn at x equals 3 would equal 54. And the instantaneous rate of change of the function at 3 is 54. Next, we're going to take a look at the square root function. Now, a few things to remember. When we are finding the instantaneous rate of change in radical functions, we need to rationalize either the numerator or the denominator. Now, to rationalize the denominator means to multiply both numerator and denominator by the conjugate of the denominator. So it means to multiply by the conjugate of the denominator. We're talking about multiplying both parts of the fraction, right? So both numerator and denominator. Now to rationalize the denominator, means to multiply by the, I meant the numerator here, to multiply by the conjugate of the numerator. So both sides of it, right? Both parts of the fraction. So let's take a look at the square root of x minus 1. We're trying to find the slope of the tangent at 17. So first, we're going to find k of 17. Then we'll find k at 17 plus h. And then we have to sub in and simplify. So k at 17 would equal the root of 17 minus 1. That would be the root of 16 or 4. K at 17 plus h would be equal to the root of 17 plus h minus 1. So that's root of 16 plus h. So we're going to say the limit as h approaches 0 of k at 17 plus h minus k at 17 over h would be the limit as h approaches 0 of root of 16 plus h minus 4 over h. So we are rationalizing the numerator, which means that we're multiplying the numerator by the conjugate and denominator by the same number. So the conjugate of the numerator is 16 plus h plus 4, 16 plus h plus 4. So this will change to root of 16 plus h squared minus 4 squared, and that will be over h root of 16 plus h plus 4. So that would be limit as h approaches 0, 16 plus h minus 16 over h root of 16 plus h plus 4. So notice that now h will simplify to give 1 over root of 16 plus 0 plus 4. So that's 1 over 8. Now you can try the second example. It's very similar to what we just did. And now we're going to take a look at a rational function, and we'll find the slope of the tangent at the given point. So same idea. Here we're going to start with finding p of 2, and then p at 2 plus h. And then we're going to find the limit as h approaches 0 of p of 2 plus h minus p of 2 over h. So p of 2 equals 1 over 2 minus 1, 1. P at 2 plus h equals 1 over 2 plus h minus 1, or 1 over 1 plus h. So the limit as h approaches 0 of 1 over 1 plus h minus 1 I'm going to write this over 1 as well. As h approaches 0. We're going to give the denominator 1 plus h. And then we have the limit as h approaches 0. And then we have 1 minus 1 plus h divided by 1 plus h over h. Simplify some more, almost done. We have 1 minus 1 plus h, that would be negative h over 1 plus h divided by h. Which is the limit, again, as h approaches 0 of negative h over 1 plus h, can make this a fraction, multiplied by 1 over h, which is negative 1 over 1 plus h, or simply negative 1 over 1 plus 0, negative 1. So in this case, the slope is negative 1. Now you can try with the next equation. It works in the same way. And I want to move on to question 4, where we have a combination of a radical with a rational function. So we are about to find the slope of the tangent at the given point. We are given the value of y at 1. So we know that we are drawing the tangent at x equals 1, and q of 1 is given to be 1/2. So we need to find q at 1 plus h. So that would be 1 over square root of 5 minus 1 plus h. So that equals 1 over the square root of 4 minus h. So the slope would equal the limit as h approaches 0, long low line. So we have q at 1 plus h minus q at 1 divided by h. So q at 1 plus h is 1 over root of 4 minus h minus 1/2 over h. That's the limit as h approaches 0. We're going to try to make the denominators the same by multiplying by root of 4 minus h. And what we get here is multiplication by 2. So the common denominator will be 2 root 4 minus h. So here we go. And numerator would be 2 minus the square root of 4 minus h. And that would be over h. So that's the limit as h approaches 0. 2 minus root of 4 minus h over 2 root 4 minus h times 1 over h. Okay, so we turn this division into multiplication, okay? Now the idea is that we want to simplify h, because h is about to become 0. And if h is 0, you will make denominator 0, expression undefined. So we're going to say that this would be the limit as h approaches 0 of. So we're thinking we need to bring some h in here. And the only way to bring h in the numerator is by multiplying by the conjugate of the numerator. The conjugate of the numerator is 2 plus root of 4 minus h. So now we have h times 2 root of 4 minus h times 2 plus root of 4 minus h. Now in the numerator we'll have 2 squared minus root of 4 minus h squared. That is 4 minus h over 2h root 4 minus h times 2 plus root 4 minus h. That's the limit as h approaches 0 of negative h will give positive h, 2h root 4 minus h, 2 plus root 4 minus h. So the h simplifies to leave us with 1 over 2 root of 4 minus 0, 2 plus root of 4 minus 0. So this would be 1 over 4 times 4, or 1 over 16. So in the next example, we're going to take a look at the equation of some function. We want to find the point where the tangent will be parallel to the line y equals 8x. So this is a thinking question. So first write the information. 3x squared minus 4x. We want to find where is the tangent parallel to y equals 8x. So that means that we want to find out the point where the tangent will have a slope of 8. So we're going to get started from the equation of the function. And we're going to say that we're going to let a point a f of a be the point where the tangent is drawn with a slope of 8. So the slope would be equal to the limit as h approaches 0, f of a plus h minus f of a over h. So that's the limit as h approaches 0. Now f of a plus h will be 3a plus h squared minus 4a plus h. F of a, on the other hand, will be 3 times a squared minus 4 times a. And that will be over h. So this is 3 a squared plus 2ah plus h squared minus 4a minus 4h minus 3a squared plus 4a divided by h. That's the limit as h approaches 0. We got 3a squared plus 6ah plus 3h squared. Then minus 4a minus 4h minus 3a squared plus 4a. Everything over h. So let's check and see what we can simplify in here. So we have 3a squared and negative 3a squared. We have negative 4a and positive 4a. And the rest of the terms are n still. So the limit as h approaches 0. So I'm going to start with the highest degree term, 3h squared. And then we have 6ah minus 4h over h. So we can take h out. So that's 3h plus 6a minus 4 over h. H will simplify, and the limit will be 3 times 0 plus 6a minus 4, or 6a minus 4. Now we know that this would equal 8. So that will make 6a equal to 12. And that in return will give the value of a equal to 12 over 6, or a equals 2.